Welcome to the hydraulics and flight control software. In this video I'm going to show you its interactive nature. Initially we're going to have a look at some of its basic features. We'll then inject a major B system leak. We'll run the QRH and then we'll deploy the flaps using the alternate system. The software consists of the main schematic, which if we click on its background you can drag it in any position you want and zoom in to look at a particular feature, zoom out or reset back to its original position. There are various control panels and windows within the system. As we use the flight control panel as an example, you can see we can drag that anywhere on the screen. We can zoom in and we can zoom out. And if you ever wonder what information a light is telling you, if you go to the options menu and under view, select light information and just roll over any of the lights, it will tell you what the light means. What I'm now going to do is set up the system for the example that follows, and we're going to look at a major leak on the B system. But we're going to have the aircraft airborne, which we are at the moment. We're going to make sure all the pumps are on. The oil damper can go on. And just to test the system, we go to Master Caution Recall. If we reset and do a recall, you can see the system is now fully functional. I'm going to inject a major B system leak by going to the faults menu, hydraulic leaks, major B leak. You'll see the hydraulic fluid is disappearing, and you can also see that on the lower display unit. If you're not looking at the lower display unit, the first indication that you'll have in the flight deck is the Master Caution Recall coming up with hydraulics. So what do we see in the flight deck? First of all, we've got our hydraulic message. If I just reset and do a recall, that's now telling us that we have a hydraulics issue, and we also need to look at the flight control panel. I'll reset that for a moment for the faults to come in. We have seen that on the lower display unit that the quantity is 0 now in the B hydraulic reservoir, and there is no pressure in the B system at all. This pressure value comes from the sensor here. We'll also see that on the hydraulic panel we've got two low pressure lights. One relates to the electric hydraulic pump on the right side, and we've also got the low pressure for the engine driven pump on the right side. If you click on either of these, then that shows you what the associated light is on the schematic, and so obviously this pressure transducer is giving the low pressure, which is related to the engine hydraulic pump. Looking at the hydraulic flight control panel, we see we have got a low pressure on flight control B. If I just go to 100% on the schematic and click on this light, you can see that it relates to this light here. So it's this transducer which is driving this low pressure light. We also have the field differential pressure light, and that is effectively telling us that there is a differential pressure between the A and the B system. We now need to put a plan in place how we're going to deal with this problem, and as part of that, in the next section we're going to run through the QRH. I'm now going to go through the salient points of the QRH. It will direct us to switch flight control B to standby rudder, and that energises the standby system, and it will tell us to switch off the affected hydraulic pumps. It will tell us that this will be a flaps 15 landing and not to use the auto brakes. It then goes through the operative items in the system, which I'm going to summarise by looking at our schematic. First of all, you'll see the auto brakes are associated with the normal brakes, which we have lost, so hence that's why we're not going to use auto brakes, but we still have the alternate braking system to use. You'll see that the right reverser is now being picked up by the standby hydraulic system. The standby hydraulic system is not as powerful as the main B system, so the deployment and retraction of the right reverser will be a little bit slower than normal, so just be aware there may be a little bit of asymmetric thrust when we do that. You can see that the red X's in the rest of the system are showing what we've lost. For example, we've lost autopilot B, but we still have autopilot A available to us. We've lost flight spoilers on the B side, but we still have some on the A side, and we've also lost the alternate nose wheel steering, but we have the normal nose wheel steering. Regarding the flight spoilers, if you go to the wing surfaces and click on flight spoilers, this will show you that the B system is 3 and 5 on the left wing, and on the right wing it's the 8 and number 10 spoilers. So we've obviously lost that, so we've effectively lost 2 per wing. That will affect the roll rate of the aircraft and also the effectiveness of the speed brake. The main issue is the deployment of the leading edge and the trailing edge flaps. You can see that the red X is saying they're not operational now that we've lost the B system, but the orange box around them is our way of saying that there is another way of doing it, and that is via the alternate flap system, and we're going to deploy those flaps using that in the next section. So we're ready for the approach now, so I'm now going to show you how we'll deploy the flaps using the alternate system. First thing we'll do is going to arm the system, and you can see that the leading edge has now gone into the alternate mode, and the trailing edge flaps are now via the electric motor. To show what's going on while we do this, I'll bring up the windows showing the flaps and slats and also the flap lever. So at the relevant speed, we'll call for flaps 1. We'll select flaps 1. Nothing will happen, and we expect that, but we do this just to reduce any hydraulic locks within the system. And if I momentarily now flick down the alternate flap switch, you will see that the leading edges fully deploy. Holding that switch down further, the trailing edges now run to 1. At the relevant speed, I'll call flaps 5. Again, we select the flap lever to 5, and then we use the alternate switch to down and run the flaps out to 5. You will notice that although the leading edges are fully deployed, you still have a leading edge flap transit light. This is normal with the alternate system. As the trailing edges go through flaps 10, that will disappear and revert to its normal indication. So let's run our flaps finally to our landing flap position, our flaps 15, and running those using the electric motor. As you go through 10, you see the light is now correct, and we'll stop there. We have flaps 15, and we are ready for approach.